Hi, I'm Fredrik Sandin, and in this module I will tell you more about knowledge representation. So in general, intelligent agents need knowledge about the environment, for example, to reason and to act in this environment. And complex domains such as autonomous driving or shopping on the internet require flexible knowledge representations. And the question is, how can we represent this knowledge about things like actions, space, time, thoughts, or driving? In principle, there are several different things that we may want to represent, like objects. The name and attributes of objects, like a rose, have a color, and it has something called leaves. Events, things that occur in the environment, like someone running or walking or meeting someone else. And performance, how to do things. Can also be facts, observed relations in the environment, or observed objects with names in the environment. It can be meta-knowledge, so knowledge about other knowledge. And we may also want to represent the whole knowledge base, a collection of sentences in some knowledge representation language. And one example of a knowledge base is DBpedia that you can find on the web. And there are some different principal knowledge representation techniques, and I will tell you about two of these. So one very common technique is frame representation, where we have a record-like structure, a collection of attributes and values, and these frames can be collected into collections of frames. And here is an example of a movie frame, where we have attributes, title, country, and year. And for these attributes, there are corresponding values, Ragnarök, Sweden, and the year 2020. Another technique is to use a semantic network representation. And the semantic network is a graph that represents semantic relations between concepts. So the nodes in this graph are the concepts, and the edges are the relationships between the concepts. And you can see an example here of a mammal. So a mammal has a spine, and a mammal is a kind of animal. And fish is an animal too, and fish lives in water. Also whales lives in water, and whales are mammals. The task to represent abstract concepts that occur in many different domains is the primary focus of ontological engineering. So the general framework of concepts is called an upper ontology. And the upper ontology is a graph with general concepts at the top and more specific concepts below. And the aim is to have a general purpose ontology that is applicable in different special purpose domains, with addition of some domain-specific definitions or axioms. And one example of this is web ontology language that is typically used to describe upper ontologies. A limitation of ontology engineering is that some aspects of the real world are difficult to capture with first-order logic and graph-based semantic representations. So most generalizations have some exceptions or hold true only to some degree. For example, tomatoes are red is a useful rule, but it is not always true because there are tomatoes that are green, yellow, orange, or have different colors, etc. And such exceptions appear in most domains, and they somehow needs to be handled. That task is not what we are trying to understand here. So ontology engineering is about defining these semantic structures, the graphs that define the relationships between the symbols. And the task to translate special purpose knowledge between different domains is actually an open research problem. So in summary, knowledge can be represented as collections of attribute value frames or as concept relationship graphs. And the general purpose ontology can be used for knowledge representations to organize and interconnect domain-specific knowledge. Natural things cannot be defined completely in logic, but attributes of natural things can be represented in this way. Thank you for listening.